Dear students, welcome back to this video and this particular question. Actually, some students approached me individually to have the solution of this integral. So I decided to make the solution with a video recording so that any of you can find the solution easily. So let us know how to find the solution of this integral. You can say how to evaluate this integral. As you have already learned a lot about the double and triple integrals with constant and variable limits, you can see this is a double integral with variable limit. The limit of y is varying from 0 to 1 minus x, and limit of x varies from minus 1 to 1. Because y has the variable limit, we will first integrate with respect to y. So first let us name this integral I. It will facilitate us for short writing. And now, because first we will integrate with respect to y, so this term, you can see, focus this term, x to the power 1 by 3, this has no role during integration of the y integral. So let us write the integral as minus 1 to 1 x to the power 1 by 3, 0 to 1 minus x, y to the power minus half, 1 minus x minus y to the power half, dy dx. So what I am planning to do is we will let this integral as I1. So let us write this as I1. So let I1, let I1, and why I am writing this as I1, just to avoid the confusion. So, and in order to facilitate the solution of the problem in parts, so let I1 be 0 to 1 minus x, y to the power minus 1 by 2, 1 minus x minus y, 1 by 2 dy. Or you can also say avoid writing this let and write this integral as minus 1 to 1 x to the power 1 by 3 I1 dx, and now I1 is what we have taken. So now we will first solve I1. So you can see that in this integral I1 x is constant. So if we take the substitution, y is equal to 1 minus x z. And why I am taking this substitution? Because this is really a type of tough type of integral. So if we take y as 1 minus x into z, the limit of the y, lower limit of the y will remain 0, but in upper limit, when you put 1 minus x, y is equal to 1 minus x. So you see this y is, when you put 1 minus x, so 1 minus x is equal to 1 minus x z, and this will imply z is equal to 1. So limits will become constant, and we will get the integral of type beta function. So this is the reason why I have taken y is equal to 1 minus xz. So if y is equal to 1 minus xz, you can write dy as 1 minus x dz. This now I have already told you, when you will put y is equal to 0, z will become 0, and when you put y is equal to 1 minus x, z will become 1. So limits have become 0 to 1. Then y will be replaced by 1 minus x into z, and this whole power minus half. Then 1 minus x, 1 minus x minus 1 minus xz, this and this. 1 minus x is 1 minus x, and y is 1 minus xz, this power half and into uh, this video actually is placed on wrong position, so I am writing this on the next page. So this will become I1 as this 0 to 1 minus xz, and this power minus half, and then 1 minus x minus 1 minus xz, and this whole power half, and then dy is 1 minus x dz. So this is our integral. You can see that in the capital bracket 1 minus x can be taken common. So you can write this as 0 to 1 minus x to the power minus half, z to the power minus half, then take 1 minus x to the power half common from the capital bracket. So 1 minus x to the power half, and inside the capital bracket it remains 1 minus z to the power half, then 1 minus x dz. Now you can observe that this 1 minus x to the power minus half and 1 minus x to the power half will get cancelled. Then these factors will cancel each other. So we will get 1 minus x 0 to 1 z to the power minus half, and 1 minus z to the power half dz. And this is beta function. I have already told you about beta function, and if you do not remember this time, so see this throughout solution process, then see what is beta function and come back to the question again, then you will get it more clearly. So this we can write as 1 minus x beta of 1 by 2 3 by 2. Now beta of 1 by 2 3 by 2 is constant, so we have evaluated I1 as 1 minus x, this beta. Now beta, value of beta will be calculated separately and put I1 in the integral I. So we will get I is equal to minus 1 to 1 x to the power 1 by 3, and I1 is 1 minus x beta 1 by 2 3 by 2 dx. This is our I. Now beta can be taken outside, so we have beta 1 by 2 3 by 2. This is a constant term, simply a factor this, and x can be written as x to the power 1 by 3 minus x to the power 4 by 3 dx. So this is our integral, and you can integrate it very easily. So we have beta 1 by 2 3 by 2, and the integral become 3 by 4 x to the power 4 by 3 minus 3 by 7 x to the power 7 by 3, and the limit applies from minus 1 to 1. Now you can put these limits. So before putting these limit, let me evaluate beta for you. So beta is gamma half into gamma 3 by 2 by gamma 1 by 2 plus 3 by 2. So this is gamma half is root pi. You already know gamma 3 by 2 is 1 by 2 root pi. You already know this, and denominator becomes gamma 2, and gamma 2 is just 1. So we get this pi by 2. So beta is pi by 2. This beta 1 by 2 3 by 2. So what we finally get is I is equal to pi by 2, and then put the values. You can take this 3 common inside from inside the vectors, so we will get 3 pi by 2, and then inside the bracket 1 by 4 x to the power 4 by 3 minus 1 by 7 x to the power 7 by 3, and still the limit remains to put. So now we will put the limit. Means you have obtained I as I is equal to 3 pi by 2 1 by 4 1 to the power 4 by 3 minus 1 to the power 4 by 3. This minus 1 by 7, and let me do this curly brace so that it will become more easier for you to connect. This is curly brace, and again this is curly brace. So we have 1 to the power 7 by 3 minus 1 to the power 7 by 3, and this is the evaluation of I. Now you can see that I 1 to the power 4 by 3 is 1, 1 to the power 7 by 3 is 1. So you can further write it as 3 pi by 2, then 1 by 4 minus 1 by 7. This is the part that you can easily compute, and then minus 1 by 4 minus 1 to the power 4 by 3, and plus 1 by 7 minus 1 to the power 7 by 3. This part needs to be evaluated with the help of complex numbers. So you can evaluate the first part easily, and this becomes 3 pi by 2, and this is 7 minus 4 by 28 means 3 by 28, and let us write the second part as C. So we just need to evaluate the C as minus 1 by 4 minus 1 to the power 4 by 3 plus 1 by 7 minus 1 to the power 7 by 3. And again I am saying, if you do not you are not especially required to obtain this C, you have put the value in this form, you have put C in this form, and you have done, means you have evaluated. So you can leave at this point. Now on the further as a further evaluation, I am going to find the value of C, but this may be beyond your scope. So let us find the value of C. So by involving the complex number, minus 1 is written as e to the power I pi, and this means minus 1 to the power 4 by 3 can be written as e to the power minus 4 pi by 3 I, and that means cos 4 pi by 3 minus I sine 4 pi by 3. So you know the values of cos and sine. You can put these values, and we get minus 1 by 2 minus I root 3 by 2. Similarly, minus 1 is equal to e to the power I pi. So minus 1, and let me change the color so it will become easier for you to understand. So this similarly minus 1 to the power 7 by 3, this will become e to the power minus 7 pi I by 3. So you will get cos 7 pi by 3 minus I sine 7 pi by 3, and you will get 1 by 2 plus I times root 3 by 2. Now you can evaluate C. So let us see what the constant C becomes. The C can be written as C as minus 1 by 4, and we have evaluated the value, so it is minus 1 by 2 minus I root 3 by 2, and plus 1 by 7, we have again evaluated the value of minus 1 to the power 7 by 3 also, so this is 1 by 2 plus I root 3 by 2. Now you can simplify this further. So this is 1 by 8 real parts. I am collecting real parts first. 1 by 8 plus 1 by 14. So this is the real part, and then the imaginary part I root 3. This I root 3 1 by 8, 1 by 4 into 1 by 2 plus 1 by 14. So again you can calculate these things. So you will get 7 by 56 plus I root 3 into 7 by 56, or you can say 7 by 56 1 plus root 3 I. So this is the value of C. If you require this precise answer, you need to put this value in the integral. And in the terms of these values, this value of C, we will get the integral as I is equal to 3 pi by 2, 3 by 28 plus 7 by 56 1 plus root 3 I. You can further uh, take simplification of these two real numbers, 3 by 28 and 7 by 56. So you get 3 pi by 2, and we have 13. 13 by 56, this is the real part, plus 7 root 3 by 56I, this is imaginary part. So this is the actual evaluation of the integral we have been given. This is the actual value. Now the value of the integral depends upon the need. If suppose the integral represents evaluation of some real integral on some surface, and that cannot have the imaginary value, then 3 pi by 2 into 13 by 56 will become its real value. And if the integral may include the imaginary numbers, then this is the actual evaluation of the integral. You can approach me for more questions. Whenever you approach me, I usually provide you the solution immediately. But the videos serve for each and everyone, every of my students, my former students, and others who are not my students. So you can provide your questions in the comment box also. Thank you for watching this lecture.